question, we're given an equation, y equals negative x squared plus 5x. This equation represents the path of a ball, okay? So someone's throwing a ball, or sorry, they're not throwing it, what is it? A golf ball. They're hitting a golf ball, and it's represented by this equation. Does anyone remember what the standard form is for a quadratic relation? We did this yesterday, yeah?
Y equals ax.
Good. Plus x plus c. Good. So in our equation we have negative x squared, right? Whoa. Negative x squared. And what is my plus c in our equation? Plus 0, right? So just by looking at the equation, does anyone remember what the c value tells us when it's written in this form? Nika? Yeah, this is the y-intercept. You're going to discover this when we graph it, but I just wanted to kind of review that. And our a value is negative what? 1. What does the a value tell us if it's a negative? How's the parabola going to open? Down. So we know the parabola is going to start at 0, right? The y-intercept 0, and it's going to open down. It's going to look something like that. We have to figure out what the points are, though. Okay? We're going to plug in values. If the distance is 0, can you calculate the height? Okay, which variable represents the distance and which one represents the height? Is distance x or y in the equation? Okay, and height is y. So let's just choose values for distance. We'll go from 0, counting by ones. Okay, you're going to use the equation y equals negative x squared plus 5x. For each value of x, find the value of y. So if x is 0, well, we can do the first one in your head. If the x value is 0, what's y?
0.
0. We know the first point on the graph. We know the graph's going to start at 0, 0, and we already knew that from the equation. Okay, so when we complete the table, these are the values we get. Let's calculate the first differences before we graph this. So remember, you're always subtracting the second number from the top number. So 4 take away 0. What's 4 take away nothing?
4, 4.
What's 6 take away 4? 6 take away 6.
0.
4 take away 6. Negative 2, yes. 0 take away 4. Negative 4. Okay, that's the first differences. To find the second differences, look here. Shantae. 2 take away 4. What's 2 take away 4? Negative 2. What's 0 take away 2? Good. What's negative 2 take away nothing? Yes. And what's negative 4 take away negative 2? Negative 2. And remember what we learned yesterday. The second differences are all the same. So again, this proves that this is going to be quadratic. And the second differences are all negative. What does that also tell you? It's going to open down, which we already know from the a value as well. In order to graph this, you only need your x and your y values, right? We can take these points and plot them on the graph. So we've already plotted the first one. If x is 0, y is 0. So remember x and y. You guys are going to choose a scale, okay? And I want you to plot the next 5 points on your graph. Okay, so I chose a scale of 1. First point is 0, 0. Second point is 1, 4. Once you plot all the points, I want you to draw a smooth curve. That was pretty good. Okay, to connect all the points. Think about this for a second. If the parabola, we talked about yesterday, parabolas are symmetrical, which means if I draw an imaginary line down the middle, we know that the two sides are equal to one another. Okay? So this line, this imaginary line, is called the axis of symmetry. Okay, this is an axis of symmetry. We need to figure out what the equation for this axis of symmetry is. Well, where does this line, what does it pass through? What does it eventually end up hitting?
Between 2 and 3.
But what part of the graph does it hit? The x-axis, right? it's going to hit the x-axis. So the axis of symmetry is written in the form x equals something. We need to know where that point is. Yes, you can look at a graph and figure it out, but I'm going to show you how to do it without using a graph as well. But remember we talked about axis of symmetry means that both sides of the parabola are equal. So if I take the midpoint, so the middle of any two y coordinates, would you agree that this point right here is directly in the middle of these two y coordinates? Is this point here directly in the middle of these two coordinates? This point directly in the middle of these two? Okay, so you can actually use your table. You can actually choose two coordinates that have the same y value. Which two coordinates in your table have the same y value? Let's do this one. 1 and 4, and these have the same y value, right? That's this point here and this point here. They're at the same level. If I find the midpoint of those 2 points, would everyone agree that it's going to be my x value, my axis of symmetry? So we're going to find the midpoint. Well, this is located at, what's the x value for this point? 1 and 4, right? 1 and 4. I want to know what lies in between 1 and 4. What's the middle of 1 plus 4? So divided by 2. What's 1 plus 4 divided by 2? 2.5. Okay, let's check. Let's find another 2 points. What about
2 and 6.
0 and 5? These are on the same level. 0 plus 5 divided by 2. What's 0 plus 5 divided by 2? 2.5. We get the same answer. What about these 2 points up here? Those were at, they have the same y value, right? 2 plus 3 divided by 2 equals 2.5. So what's my axis of symmetry? X equals 2.5. If we find any single point on my axis of symmetry, all of these, any single point here is located at 2.5 and something. It moves up and down, right? Your axis of symmetry is a straight line that's located at 2.5 for the x value. It's the point where the parabola changes direction. So in this case, it's located at the very top, somewhere up here, right? Of the parabola. This is the vertex. It's the point where the parabola changes direction. So the parabola increases and all of a sudden it hits this point and it decreases, right? Do you know one of the coordinates of the vertex from looking at this graph? Okay, the vertex is actually located directly in the line of symmetry, right? Your line of symmetry, your axis of symmetry passes through the vertex, correct? So I know that my vertex is going to be located at 2.5 and something. I can't read that on this graph. It's a mess, right? We don't know what the y value is, and it's going to be a decimal. Even if you look at your graph, it's hard to see where it's located. Remember at the very beginning of the question, we were given an equation. An equation has an x and a y value. That's a point on a parabola. Do you know the part of the coordinate for this parabola? Do we know an x value? Can you solve for y? If x is 2.5, plug it into your equation, find y. So all we're doing is we're using our equation and I'm replacing x with the value of x, which is 2.5 in this case, because I want to know what's my y value when x is 2.5. Once we simplify this and solve, y is 6.25, which means that the vertex is located at 2.5, 6.25.
Made with Doodlecast Pro.